Education Learning Conference. I'm Lindsay Survey with McGraw-Hill Education, and I will be the webinar moderator for today's session. Before we get started, I'd like to go over a few quick housekeeping items. This event is being presented in listen-only mode, which means you will be able to hear the presenter, but she will not be able to hear you. However, that doesn't mean you can't participate. There will be polling questions throughout the presentation, and in addition, we will hold all questions until the end, and you are welcome to type them in the Q&A panel on your screen throughout the session. Joining us today is Patrice Riggin. Patrice's session, titled Effective Math Instruction, will help you determine how to evaluate and implement an effective math solution to meet the rigorous standards of today. Patrice Riggin has more than 28 years of experience in teaching SRA direct instruction, DI, in both regular and special education classrooms. Patrice earned her BA in Elementary Education, Special Education from Rhode Island College and a Master of Instruction, MI, degree from the University of Delaware. I'd now like to turn the session over to Patrice.
Thanks, Lindsay. As we get started, we wanted to start with a survey question. Our first question is, how long have you used Connecting Math Concepts? With the choices being that you've never used it, less than a year, 1 to 2 years, 3 or more years, or you've only used the previous edition. Go ahead and click on the responses and submit it, and then we'll move on from there. It looks as though most of you have used the program for a year or two. Actually, that's 100% of the people who responded. So it seems that some of you have some information about it, but not necessarily know a little bit more. So we're going to get a little bit into more depth with the program. With the Common Core State Standards, we now know what to teach, and that has been standardized throughout the United States. But the biggest challenge remains, how do we reach all of our learners, especially those who are at risk for difficulty in math? Connecting Math Concepts provides an alternative in math instruction. Connecting Math Concepts is going to be different from most math programs in several critical ways. It's research-based, based on current research indicating which effects are most effective, particularly with students who are at risk for difficulty in math. The program was extensively field-tested prior to being published, tried out in real classrooms with real teachers and students throughout the United States. The organization of the instruction is a critical difference, and one that we'll be looking at in a little bit more depth in just a few minutes. Lessons in the program are designed to be very highly interactive, with the teacher using a consistent language of instruction to help particularly those at-risk students to really access math instruction. And finally, there's a difference in terms of the emphasis on testing and remediation in the program. In the program, we're not looking at tests just as a way to give grades, but as indicating where additional remediation needs before continuing with instruction. In its final report in 2008, the National Math Advisory Panel stated that for students who are at risk for learning difficulties in math, that explicit instruction is most effective. When they talk about explicit instruction, what they mean is, having trouble moving slides, sorry about that. See if I can't get this going a little bit better. Clicking next slide and it's not happening. Got it. That teachers are providing clear models for solving problems using a wide array of examples. That students receive extensive practice in using those newly learned strategies and skills, and that students are provided an opportunity to think aloud, and that they're receiving extensive feedback from their teachers. In Connecting Math Concepts, you'll see that explicit strategy instruction is provided throughout, starting with focusing on critical pre-skills. In teaching students to do subtraction problems that involve regrouping, it's built on a conceptual understanding of place value. That the place value is 73, a simple place value is 70 plus 3, but that it can also be written as 60 plus 13, which also equals 73. So that conceptual understanding of place value is built first. Following the conceptual understanding, we're moving to the procedural. Students are getting extensive practice in applying the strategy of regrouping with column subtraction problems. Initially, there's lots and lots of guided practice, with the teacher walking the students through the problems prior to students becoming independent and working on them. Once that fluency with the procedural knowledge is built, we're going to expand it and apply it in many other contexts, including problems that involve estimation, as well as doing it with word problems as well. It just took a second to load there. So once we've given the conceptual understanding, we're teaching the procedural knowledge, and then moving to application. Now, all programs now address the Common Core state standards, but one aspect of most traditional math programs has not changed, and that's the organization. Most traditional math programs still follow what's called a spiral curriculum. The books are organized into chapters or units or topics, and the students next see that topic the following school year. The big challenge for those of us who work with at-risk students is, what will they remember a year later? Direct instruction programs take a different approach, what we refer to as track or strand sequencing. In track sequencing, each track focuses on one topic, and the exercises within any track change very systematically. You should have a handout with the scope and sequence for level D of connecting math concepts. Rather than organizing the program into chapters or units or topics, we're looking at instructional strands, and each strand is focusing on a different aspect of math. In level D, for example, work on story problems begins at lesson 9 and continues through lesson 64. During that time, part of each lesson focuses on word problems. And when we look at any one individual lesson, what we're looking at is a cross-section of those different instructional strands. So we're working on skills from a variety of strands within that same lesson. The track sequencing in a direct instruction program allows for a very gradual introduction of skills. It also allows for continuous review and expansion with adequate practice and systematic review. In addition, when we're teaching multiple concepts within a lesson, it helps to keep students engaged in their learning. Also, in their final report, the National Math Advisory Panel mentioned that a major goal for K-8 math instruction should be proficiency with fractions, because fractions is a foundation for algebra. And why is algebra so important? Well, research indicates that students who fail Algebra 1 are over 4 times more likely to drop out of high school than kids who pass the first time. So algebra is a critical skill. But when we think about initial instruction in algebra, it's often limited to fractions like 1/2, 1/4, 1/3, maybe 3/4, 2/4, leading students to have some misunderstandings about fractions, that they may be always with a 1 on the top, and that they're always part of something. National Math Advisory Council again said that conceptual and procedural knowledge about fractions with magnitudes less than 1 does not transfer to understanding fractions with magnitudes greater than 1. Those improper fractions that students will be dealing with in algebra. Again, that understanding of only working with fractions with very limited ranges leads kids to think that it's always just part of the pizza. In a currently popular third grade math program, fractions is topic 12. On consecutive lessons, students divide regions into equal parts, write fractions to describe those parts of the whole, work with fractions in sets, benchmark fractions, equivalent fractions, they compare fractions, work with fractions on a number line, add fractions with like denominators, subtract fractions with like denominators, and then take the topic test. Essentially, covering everything in third grade fractions within about a 2-week topic. Let's compare that to the instruction of fractions in third grade in connecting math. In Connecting Math Concepts, fractions are introduced beginning at lesson 29 of level D, again the third grade level, and it's a major instructional strand. It begins with the conceptual understanding of fractions, fractions that have a magnitude both greater than and less than 1. In the initial instruction, the program is going to use language that's accessible to the students, talking about the top number and bottom number of the fraction, introducing the academic vocabulary, numerator and denominator, after students have a better conceptual understanding. In the initial instruction, students learn that the bottom number tells how many parts are in each unit, and the top number tells how many parts are shaded or used. Right from the beginning of instruction, students are exposed to fractions that have a magnitude greater than 1 as well as less than 1. So in fraction A, there are 5 parts in each unit, the bottom number, and 3 parts are shaded, the top number. Where in fraction C, there are 3 parts in each unit, again the bottom number, and 4 parts are shaded. So we're dealing with a fraction that is greater than 1. In the following lessons, students have practice in reading fractions, building fluency with fractions. They'll start with the easy fractions that we just add the th to, like ninths, eighths, fourths. And then later work the more challenging fractions, the seconds, the halves, thirds, fifths, where we're not just saying the number. They also learn to identify numbers or fractions that are equal to 1, and that's going to be used later on in comparing fractions. A little later on in fraction instruction, we're working on fractions on a number line. Fractions on a number line is a challenging concept for students, and it's one that is very difficult to teach without working with fractions that are more than one whole unit. Students also learn to add and subtract fractions, but they're not just doing it rotely, adding fractions with like denominators and subtracting fractions with like denominators. They need to make a critical discrimination. Can they work the problem the way that it's written? In the first example, 2 ninths plus 1/2, they can't because the bottom numbers are not the same. However, in the second one, 3/5 plus 6/5, they can. One of the biggest confusions students have in later fractions instruction is the difference between adding and subtracting fractions and multiplying fractions. And we want to ensure that our students don't have those misunderstandings as we carefully go through the sequence of instruction. Students use what they know about fractions equaling 1 or being greater than less than 1 in comparing fractions, and relate fractions to multiplication and division in changing whole numbers into fractions. They also work with mixed numbers on a number line and equivalent fractions. At the same time, continuing to review and practice the skills they've already learned. If you're looking at part 9 from the independent work for lesson 89, students are writing fractions for pictures. That was first taught in lesson 29, but they're still practicing it 60 lessons later. If we compare in a traditional sequence, fractions are taught during a 10-lesson topic, and the students will next see that topic at the next grade level. In track sequencing, fractions are taught over a 90-lesson span with continuous practice and review, and expanding fractions into other areas of math as well. The current edition, the new edition of Connecting Math Concepts, is a comprehensive program that is focused on standards, coherent both within and across grade levels, and rigorous in balancing conceptual understanding, procedural knowledge, and building fluency with both facts and operations. The program is commonly used both as a core for students in grades K through 5 and as an intensive math intervention for students in need of intervention in math. The program is organized into levels A through F, kindergarten through 5th grade. Since the program is often used for intervention, that letter designation enables teachers to work with students at their instructional level. So even if we have a fourth grade student who may be a year or two behind in level, we're not handing them a book that has a 2 or a 3 on it, but they might have levels C or D. The lessons typically take between 45 and 60 minutes. The lessons are going to be shorter at the lower levels. Obviously, in level A, if we're working at the kindergarten level, the lessons are going to be a lot shorter than they are if we're working in 5th grade level. And they also increase in their length as we move from the early lessons in a program into the later lessons. Throughout, we're focusing on explicit strategy instruction, as was demonstrated before with working with subtraction with regrouping. The emphasis throughout is on mastery learning and teaching students to mastery. We begin with diagnostic assessments, assessing what students' instructional level is in math to ensure that they're successful right from the beginning. There's frequent progress monitoring in the program, with mastery tests occurring every 10 lessons. And those mastery tests are not just the end of a unit, we move on to the next. Those mastery tests are going to indicate where is additional practice and review needed prior to moving on. And one of the biggest differences in the newest version of Connecting Math Concepts, in addition to the fact that it is fully correlated to the Common Core State Standards, is that there are new digital resources that make instruction a lot easier for teachers and more engaging for students. There's a real emphasis on focus and coherence. At each level of the program, most of the exercises in that level are focused on the major clusters for the standards at that grade level. So we're always focusing on meeting those Common Core State Standards. Throughout the program, there are correlation charts in both the teacher and student materials that indicate which Common Core State Standards are addressed in the lessons. These really enable the teachers to ensure that we are meeting those standards throughout. The coherence of the program is another real critical factor. Because Connecting Math Concepts was developed by a single team of authors, the coherence from the kindergarten level to the 5th grade level is a real strength. Field testing was done first at the kindergarten level and then built from one level to the next. So when looking at our example here from geometry, we can see that what they're learning at the kindergarten level about 2-dimensional figures is expanded at the next level into 3-dimensional and builds as we move up through the program. The program components are another real difference. In terms of the teacher materials for the program, there are both print and online versions. The teacher presentation books contain the fully scripted lessons for the teacher, maintaining that consistent language of instruction as we move through the program. But those teacher presentation books are also available online through the ConnectEd piece, meaning that when you're doing planning over the weekend, you don't need to take the whole book home with you. You've got it there in that form. Student materials are available, again, both in print and online, in that there are student workbooks at all levels, textbooks beginning at the 2nd grade level in level C, as well as online practice activities that both build fact fluency as well as a more firm conceptual understanding. The ConnectEd platform also provides all of the resources the teachers need in terms of record keeping. The To Inform platform becomes an online gradebook so that everything you need for planning and teaching your lessons is going to be there for you. The planning pages in the program are in the teacher presentation book and again also online every 5 lessons. And they allow the teacher to better plan instruction. The objectives are listed for each lesson. Any objective that's listed in bold-faced print is a new objective. It's a new skill that the teacher is going to be introducing in that lesson. For teachers in settings where lesson objectives need to be posted on the board on a daily basis, This makes things a lot easier because you've got those landing pages stating what your objectives are as you go through. The lessons in the program are designed to be highly interactive. Each lesson has 7 to 9 teacher-directed exercises coming from the different instructional strands. So you're not spending the entire lesson on fractions or subtraction with regrouping. You would be spending a few minutes on fractions, some time on subtraction with regrouping, work on word problems, work on facts, and moving from one to the other as you go through. Throughout, the teacher is presenting information. The students respond both orally and then in writing. The work is checked, providing immediate feedback for the students and correction of errors as soon as they happen. This is critical in having students not develop error patterns where they make those same kind of mistakes over and over and over again because they are receiving immediate corrective feedback as well as positive feedback as they go through. All lessons are then going to end with independent work, where students are getting additional practice in the skills and concepts that have been taught. We're going to be looking at a short video, it's not quite 5 minutes, that's going to be demonstrating how this interactive lesson works. The teacher is working in level D of connecting math concepts. And if any of you happen to have a series guide available, this is one of the sample lessons for level D that is in the series guide. So you might want to look at that as we're looking through it. We're going to take a look at it, and as we're going to look at how the lessons are interactive, where the teacher is presenting information, where our students responding are first orally, and then moving to written practice, and then how that work is checked. So let's take a look at a little piece of the lesson.
Here are the rules about fractions. If there are 6 parts in each unit, the parts are called 6. What are the parts called? Get ready. 6. Yes, 6. If there are 9 parts in each unit, the parts are called ninths. What are the parts called? Get ready. Ninths. If there are 3 parts in each unit, the parts are called thirds. What are the parts called? Get ready. Thirds. What are the parts called if there are 4 parts in each unit? Get ready. Fourths. What are the parts called if there are 7 parts in each unit? Get ready. 7. What are the parts called if there are 14 parts in each unit? Get ready. 14. What are the parts called if there are 5 parts in each unit? Get ready. 5. What are the parts called if there are 3 parts in each unit? Get ready. 3rds. Nicely done. How many parts are in each unit? Get ready. 9. Listen again. How many parts are in each unit? Get ready. 9. So what are the parts called? Get ready. 9. Yes, ninths. This fraction is 2 ninths. What's this fraction? Get ready. 2 ninths. Yes, 2 ninths. How many parts are in each unit? Get ready. 8. So what are the parts called? Get ready. 8. This fraction is 2 eighths. What's this fraction? Get ready. 2 eighths. How many parts in each unit? Get ready. 4. So what are the parts called? Get ready. 4. Yes, fourths. What's this fraction? Get ready. 3/4. Yes, 3/4. How many parts in each unit? Get ready. 7. So what are the parts called? Get ready. 7. Yes, sevenths. What's this fraction? Get ready. 5/7. Yes, 5/7. Nicely done. How many parts in each unit? Get ready. 10. Yes, 10. So what are the parts called? Get ready. 10. This fraction is 2/10. What's this fraction? Get ready. 2/10. Nicely done. Read each fraction sitting tall. Nicely done. Eyes on the board. Here we go. What fraction? 2 ninths. Look again. What fraction? 2 ninths. Yes, 2 ninths. What fraction? 2 eighths. Yes, 2 eighths. What fraction? 3/4. Yes, 3/4. What fraction? 5/7. Yes, 5/7. What fraction? 2/10. Yes, 2/10. Time for individual turns. What fraction? Nettie.
2 ninths.
What fraction? Wesley.
2 eighths.
There you go. What fraction? Lamarcus.
3/4.
What fraction? Hannah.
5/7.
What fraction? Fernando.
2/10.
Find part 2 in your workbook. You are going to write fractions for the pictures. Touch picture A. First, you'll write the number that tells how many parts are in each unit. Is that the top number or the bottom number? Get ready? The bottom number. Write the bottom number of the fraction, then stop. Correcting pens up when you're done. What is the bottom number of the fraction? Get ready? 4. Yes, 4. Write the top number of the fraction. Go. Correcting pens up when you are done. Thank you for working quickly and quietly. What's the top number of the fraction? Get ready? 5. Yes, 5 parts are shaded. Mark it, park it, and touch picture B. Write the part of the fraction that tells how many parts are in each unit. Stop when you've done that much. Go. Correcting pens up when you are done. What number did you write? Get ready? 3. Yes, 3. Is that the top number or the bottom number? Get ready? The bottom number. Yes, the bottom number. Mark it, park it, and touch B. Write the top number. Go. What number did you write? Get ready. 1. Yes, 1 part is shaded. Mark it, park it, and touch picture C. Write the part of the fraction that tells how many parts are in each unit. Stop when you've done that much. Go. What number did you write? Get ready. 6. Yes, 6. Is that the top number or the bottom number? Get ready. The bottom number. The bottom number. Write the top number of the fraction. Go. Correcting pens up when you are done. What number did you write? Get ready. 3. Yes, 3 parts are shaded. Mark it, park it, and ready positions. Well done.
sure we all wish that our students would behave as well as the students did in that classroom. Expectations have obviously been taught and practiced. Again, each lesson is going to have between 7 to 9 exercises. This was one exercise from the lesson. The teacher first presents information orally. When she was up at the board, she was demonstrating how to read those fractions. Initially, she was using group responses, those choral responses, so that everyone in the group has a chance to respond. If she was asking questions traditional way, with a group class of that size, probably only 4 or 5 students would have gotten a chance to answer, and she would have no idea whether or not the other students have really mastered the material. So using those group responses helps to keep all students actively engaged in the learning. You'll notice that she used a signal to get the group response. Her signal allows everyone in the group the opportunity to think and then respond. Without an effective signal, the student in the group who knows it best shouts out the answer first, and everyone else chimes in. By using an effective signal, the teacher is able to have everyone in the group thinking and initiating their own response. Again, keeping everyone in the group very actively involved in the learning. You may have noticed as well that after she did the group responses, she gave some individual turns. The individual turns are a critical way of ensuring that everyone in the group has it. And you may have noticed something that she did that's very different from most traditional questioning techniques. She asked the question first and then called on the student. By doing that, she's helping to maintain everyone's attention, because we know that as soon as the students hear someone else's name, they're not going to pay attention any longer. When they began working and writing, because again, they're going to do work orally first, and when they're firm orally, move to writing. I'm sure you noticed some of the teacher's management as the students worked through there. They were directed to touch part 1, and you'll notice that every finger was there after the teacher said that. They worked through things one problem at a time. Again, this is going to help to ensure that students don't develop error patterns, so that if they do make mistakes, the teacher is able to catch them and correct them quickly. You probably also noticed pencils up and pencils down. That's a management technique that many teachers use. Because we do know that if students have a pencil in their hand, they're going to want to be writing. So we want to control that. And you can see that she was doing that throughout. So the lesson followed that pattern. As she moved to the next exercise, students would do oral practice first, do the written practice, check the work, and move on. So the interactive lessons really help to keep students actively involved in learning throughout the lesson. Let's see if I can skip over the video and hit the next slide. Got it. Okay. A little bit worried about that. We mentioned before the assessment component in the program, and we start with the diagnostic assessment. The placement tests are all located in the series guide. So again, if you're thinking about implementing connecting math concepts, that's something that you would want to get so that you can placement test to determine where your students would be. Placement tests are located beginning on page 188 in the series guide. And most placement tests have 2 sections, section 1 and section 2. If you're working with students who are new to connecting math concepts and have not already been in the program, I usually recommend just doing section 1. Section 2 of the placement test tends to have some things that are unique to the program, and they can be really challenging for many students. So section 1 is going to let you know if your students have the minimal skills necessary to begin the program. Mastery tests occur every 10 lessons. So you're teaching 10 lessons and you're giving a mastery test that's going to assess whether or not your students have truly mastered some of the critical skills and concepts that were taught in those preceding 10 lessons. Each mastery test is divided into parts, with each part of the test focused on a different skill. The in-program mastery tests are going to give the teacher 2 pieces of information. It is going to give a grade for the student on the overall test. but it's also indicating where remediation is needed before moving on to the next lesson. So even if a student has a 90% on the test, they may not have passed a part of the test. Because all of the skill development in connecting math concepts is going to build incrementally, we want to make sure that students have mastered all skills before moving on. So even if a student has gotten a good grade on the test, they may be in need of remediation prior to teaching the next lesson. The teacher's guide and answer keys are going to indicate what the criteria is for each part of the test and where the additional practice or review needs to occur. In the student assessment book, which is one component of the student materials, all of the mastery tests are located, as well as remedy pages that follow each test. So the teacher will get very specific information as to what they'll need to reteach and which parts of the remedy sheets they would use. The teacher can enter their information the old-fashioned way. Each teacher's guide has charts where teachers can record mastery test information, but it's a lot easier to use the To-Inform platform. The page that you're seeing, the smaller blue one over on the right, is a page from To-Inform. With To-Inform, you can enter the mastery test information for each student in your group. It will give you the student's grades and indicate which parts of the test the students did not master. If more than 25% of the students in your group did not master a particular part of the the mastery test, you'll be directed to do a group remedy and just to review that specific skill with everyone. But it will also indicate if there are individuals who are in need of remedies. So following every mastery test, it's critical that the teacher provide remediation for both the group and individuals who may need it. Mentioned earlier, the Connecting Math Concepts is used in two different ways. It is used in many settings as a core math program, as it was in the video that we looked, which was done at the Arthur Academies in Portland, Oregon. But it's also used as intervention. I'm currently working with schools that use the program in both ways. I would like to share with you some of the results that these schools have gotten in using Connecting Math Concepts. One of the sites is Comment Elementary School in Michigan. It's in the suburbs of Detroit. Comment was identified as a priority school in Michigan because of low test scores over a period of years. In the year that we're citing research from, and this is now their third year this current school year, but this was their first year of CMC implementation, the 2013-14 school year. Their instruction in Connecting Math Concepts did not begin until late October. That's because up until last school year, Michigan did their state testing in October. So the teachers did lots of test prep and then testing before they began their instruction, really for the next school year. The principal of the school made the decision to place students into the level of Connecting Math Concepts that met their grade level. This was something that we were really concerned about because we advocate for placement testing students and putting them in at their instructional level, but he made a decision based on what he thought would be best for his students. So he placed all the students at grade level with the exception of two groups. One was a group of first grade students who had very low math skills. These students, for the most part, could not count past 10, were not strong in number recognition, and really had no strategies for working either addition or subtraction problems. So this group was placed in level A of Connecting Math Concepts. The other exception was the sixth grade. The school was K-6 at the time, and because there was not a sixth grade level of Connecting Math Concepts, the principal placed the sixth graders into level F. So they were in the fifth grade level of the program. His primary focus for the school year was on building math fluency, building fluency with facts and operations. He stated right from the beginning that he was not as concerned about applications because his students really needed to have the basics. So what were the results? At the fourth grade level, at the beginning of the school year, only 41% of the students were considered to be Tier 1 in math based on the Ames web testing. That percentage more than doubled by the end of the school year, with over 81% of the students being Tier 1 for math computation in 4th grade. And if you're looking at the number of the students who are in red, it's barely even there. These were both the general ed students in the building, as well as the identified special education students at that grade level. Well, as I mentioned, the principal's focus was on building fluency. They also assessed how their students were doing in terms of the math applications and concepts. So they were assessed in that as well. As expected, scores in math applications and concepts were lower than they were in computation. At the beginning of the year, only 31% of the students were in green, were on level in math concepts and applications. Again, that doubles by the end of the year to 63%. Very small group as well, being in the red, and more of an at-risk group. But again, we need to keep in mind that they were really focusing on building fluency with facts and computation. Let's take a look at 1st grade. At the beginning of the year, 55% of the students, about half of them, were doing pretty well in terms of their math. But at the end of the year, 81% of the students were in the green for math computation. I mentioned that real low 1st grade group. They had a fabulous teacher who really worked to accelerate their progress as they moved through the program. By February of that 1st grade year, they had moved into level B of connecting math concepts and completed at least the first half of it by the end of the school year. So it's interesting for me, having worked with them, looking at their data, we can see that they had a little bit of a drop mid-year in winter, and then things really shot up in spring. And I attribute a lot of that to that one 1st grade group that really started reaching grade level expectations. Now, as we mentioned, the 6th grade, because there wasn't a 6th grade level of connecting math concepts, was in level F. So they were in the 5th grade level of the program. We're looking here at their scores for math concepts and applications. We're not looking at computation. We're looking at their ability to apply the skills and concepts that they learned. They went from 41% being green there at the beginning of the year to 76% by the end of the year. So even though they were placed in the program a grade level below their chronological grade level, they still made significant improvements through that school year. The success at Connect has continued with both connecting math concepts as well as reading mastery, and there's more information on their implementation through mcgraw-hill. Another implementation of connecting math concepts that I've also been involved with in Michigan is with intervention students. It's a project through one of the intermediate units in Michigan, which serves either a county-wide or, in this case, multi-county schools by providing additional support for teachers. It was an intermediate school district, and we worked with 45 teachers and paraprofessionals in 19 schools over 13 districts. So it was a rather wide area. Teachers worked with those students who were in special education as well as general education at-risk students. All the students were placement tested and placed at your instructional level. And this was an intervention in addition to core math instruction in the classrooms. Most of the special education students placed 2 years below grade level. So for example, most of the 4th graders who would have been level E had they been on level were placing into level C. So typically, our special education students were placing 2 years below grade level. Most of the general education at-risk students placed 1 year below grade level, but all were tested on NWEA at their grade level, at their chronological level. The results were analyzed. And what they found, that in all cases, the gains on their 2014-15 NWEA math were larger than what they had in 2013-14 relative to national norms. In 2013-14, which was prior to the Connecting Math Concepts implementation, the students' scores fell rather relative to the mean. So they had an effect size of -10. So they were learning less than other students at their grade level. However, in 2014-15, during this intervention, they rose substantially. With the general education at-risk students, the difference between the values in 2 years was more than half a standard deviation, greater than national norms. Students with special needs also had growth of more than half a standard deviation. In John Hattie's visible learning analysis, an effect size of 1 standard deviation is considered to be over 2 to 3 years growth within a school year, meaning that student achievement has been increased by 50% over what it would have typically. In our case, with over half a standard deviation, it indicated to us that our students were making well over 1 to 2 years growth within less than a school year. Because again, we didn't begin right at the beginning of the school year, we started into it a little bit further. So students had increased their rate of learning by 25% over what they would have without this intervention. This intervention is continuing its second year. We have more teachers and schools that have come on board. And we've also added Essentials for Algebra with some of the middle and high schools that we're working with as well. So I wanted to share with you how the program has been effective for schools and districts in Michigan, but in other places as well. And these are sites that I've worked with very specifically. One of the things that did come up in the analysis of the data when they were analyzing the NWEA is that there were 2 critical factors for student growth. That lessons were taught 5 days a week for at least 40 minutes. So often we're kind of looking for a miracle intervention. Okay, we've got 20 minutes, so we can do this twice a week. Connecting Math Concepts isn't for you if that's what you're looking at. Because we found that it was most effective when students had the instruction 5 days a week for at least 40 minutes. And the other critical factor was high teacher fidelity scores. The teachers received in-class coaching on every visit were rated for their fidelity to the program. And those teachers with high fidelity scores were the teachers whose students were most successful and made the most improvement in using Connecting Math Concepts as their intervention. Connecting Math Concepts is a direct instruction program designed to accelerate achievement, generate student confidence, as well as empower teachers. We'll take some questions in just a second, but before that, we're going to do one other polling question. If you are currently using Connecting Math Concepts, what are some of your biggest challenges? Students' conceptual understanding, building that procedural fluency with facts and operations, or the application of skills. Go ahead and click in your answers, and we'll look at that in just a second before we get into questions. So it looks like conceptual understanding is a challenge for many of you. One of the reasons for asking this is that many of you may know that mcgraw-hill has been doing a webinar series dealing with the different direct instruction programs. On Wednesday, November 4th at 3:30 Eastern Time, we're having the first webinar on Connecting Math Concepts. So we did want to see if there were any specific questions that people had that we might be able to add to the webinar as we go through that. So if you have questions, please make sure that you've submitted them, and I'll answer those now. the two questions that did come up, one is, can you use components from the old edition with the new edition? Unfortunately, the answer to that is no. It is a complete revision of the program, again, in response to those Common Core state standards. Level A of the previous edition of Connecting Math Concepts was essentially the first grade level of the program. Level A of the new edition is a kindergarten level of the program. So it is completely different in terms of the grade levels, and you really can't work the two together. Another question was, what are some of the things that people do like about the new edition? The first thing, obviously, is that it is correlated to the Common Core state standards. So you can ensure that you're addressing the standards when you're teaching the program. One of the other real nice pieces is the online component. I mentioned To Inform, which is the online record keeping, as well as having the teacher presentation book online. All the board displays are online as well. So when I was showing you the pictures from fraction instruction, and I'm going to try and pop back to one of those for just a second, what you would actually be looking at is a board display. So rather than the teacher having to write things on the board, which, as we know, pretty much necessitates turning your back to the students, which we don't want to do, you can just use the board displays. They work with the interactive whiteboard. They can be used with a projector. So it's a lot easier to go to the displays. I think I pulled one back up for you. The one that was just before this, the previous one, would have come up first, and the teacher would have identified how many parts are in each unit and write it as the bottom number. And actually, the teacher's not writing it, you're clicking, and it comes up there. And then they have the parts colored in. And they're now with this slide moving to writing it up, putting in the top number, how many parts are shaded or used in each of those. So the board displays are really nice. The teacher doesn't have to write anything on the board. It is right up there. It's far more engaging for the students. And especially if you're working for a larger group, it's much easier to see. One of my personal preferences in terms of the new program is with that kindergarten level, with level K of the program, level A. It combines many of the things that are really effective in the oldie but goodie district arithmetic into Connecting Math Concepts. So for example, the strategies that students use to initially work addition, subtraction, and algebra addition problems are much more similar to what they would have learned in discharge, to what they would have done in Connecting Math Concepts Level A, the earlier edition. So those are just some of the things that I think are things that teachers really do like about the new program. Are there any other questions? And I think I just pushed the wrong button. Okay, I'm back. I was trying to get the question slide up again and I couldn't find it. So, any other questions that you have? Well, if you have no other questions, again, I would like to remind you that on Wednesday, November 4th at 3:30, there will be a webinar for current users of Connecting Math Concepts. And we're going to be focusing on some of the things that have been challenges for teachers. We will be talking about managing groups in Connecting Math Concepts. We'll be talking about building fact fluency, which can be a challenge for many of our students. And then we'll be looking at helping our students to really be able to handle word problems as they're taught in the program, and then how to expand that into other settings as well. So if you have other questions, please ask them now. But if not, thank you very much for joining us this afternoon. We really do appreciate it.